Hello everyone, welcome to MySQL QA episode number 10. In this episode we'll have a look into reproducing and simplifying, how to get it right. So what are we talking about here? Well, if you haven't seen the previous episodes, those are really almost a prerequisite for this episode, and I'm specifically talking about episodes 7, 8 and 9. So jump maybe back on the Percona blog and go and have a look at episodes 7, 8 and 9, because in it we'll have all the various stages of reducer. So if you picture that we have a pool of possible SQL test cases, each of them representing a particular bug, and we have to start producing very short test cases for each of these individual test cases that are still quite long. Then in the first episode, episode 7, that was talking about reducer, we would have probably covered maybe about this many issues. Once you include episode 8, it would be this many issues, and once you included episode 9, although it's slightly different when we're talking about multi-threaded, but let's assume that in total we would have handled on and about 85 to 95% of all issues. So what are we talking about in this episode? We're just talking about that little leftover bit of test cases that, you know, for instance, you start reducer and your issue doesn't reproduce. So what do? If you have been watching the previous episodes, you already got quite a few ideas about how to go about things, but there might still be those few test cases that are very hard to reproduce. And so this episode in a way is a bit boring because it goes into many of the different little tactics or knickknacks that you can use just to get those test cases to reproduce as well, or how to simplify them. Like, let's say that your test case reproduces correctly, but then it's hard to simplify. It doesn't happen very often. Again, 85 to 95%, you're just going to start reducer, or you're just going to do a little bit of tweaking and it's going to run fine with maybe the skip v option, the force skip v option as we saw in one of the previous episodes, and it's going to be all fine. But there are those that are very hard and tricky, and you can spend 3 or 4 times as much time on these as you would have on a number of these altogether. Okay, so episode 7 was basically the basics, but you really need the basics. It's about an hour and a half, that episode, that goes into all the different elements of reducer and shows you various options. Episode 8 went into more detail, more advanced options. Episode 9 is slightly different. It goes into multi-threaded, so if you're doing multi-threaded test cases. And again, you know, this particular episode, episode 10, is all about handling those little that little set of remainder issues that needs to be reduced where there are problems. Okay, so for this we will basically have a look at this file. It's inside Percona QA. It's called Reproducing and Simplification, and in it there is quite a large amount of ideas and strategies that you can try step by step. After a while you start knowing them and you don't always have to go back to the file and read it, but when you get stuck, it's great to go back and have a read, because there's probably some idea, or maybe some idea that's not even in there, but just by deducing or analysis you can understand what might be possible next steps in your particular issue that you're seeing. And we'll also have a look into the automatically generated scripts which are produced by Reducer, and this we haven't seen in any of the previous episodes, I thought, but it's sort of a bit of an add-on that I forgot to include earlier. And okay, so what does this look like? So I've pasted a little bit of an excerpt here that we normally put into bug reports together with the shortened test case, and here you've got an example of how this looks in real life. So picture that you have a 5 or 6 line test case and you've pasted it into your bug report that you've logged, and you've listed which options are required, etc. Then, you know, it would still be very handy for the developer if they had some way of having a more or less exact match of the system that you're using to reproduce the bug, because one of the things that I've learned in QA quite early on is it's very hard to get a bug to reproduce if even a few variables are different between your system and the developer system. Now this is no longer an issue, and I'd say that 95% of the bugs that we log, the developers can reproduce, or the QA guys can reproduce. And I'm talking about upstream here, for example, but it does sometimes still happen, and all that is necessary then is just to go in and give a few extra advices, or maybe what happened was that the issue is highly sporadic, and so it needs to be run a number of times before it reproduces. But generally speaking, that's no longer the case. However, in early days, it was always the case. The number one comment would be, hey, we can't reproduce the particular bug that you've logged. I'm slightly overstating the issue, but I'm sure that you get what I mean. Okay, so you've pasted a bug report, and then you want to include this. You want to include that bug bundle, and basically that bug bundle is just a copy of all these scripts together with your SQL and etc. So what does the developer have to do? They just have to unpack that bug bundle, go into the epoch number underscore MyBase, and you can see that file here, and update the base path in this file, and that's the only change that's required. It's almost the only change that's required. There is just a little bit more. You can also include the source directory, but it's only really required if you want to get it to work if make binary distribution script was not used to build MySQL and JMalloc, but JMalloc is not required for upstream, so it's only if you're using JMalloc as a memory handler. Okay, so basically the only real change that in most cases you would have to use if you just have a tarball MySQL package, which most of the QA guys and hopefully developers would use as generated by make binary distribution or as downloaded from the website, then you can simply update this underscore MyBase and set it to the correct base path in the file, and then you can execute underscore init, so here underscore init underscore start and underscore cl. And what does this do? Init initializes the data directory in dev.hm, TMPFS storage, and start will start after the data directory is initialized. You can start the server with underscore start, and you can then check if MySQL is up and running by using underscore cl, and then you can just run your test case. And there's two items included, so underscore run, and then if it's a pquery test case that really requires pquery, then there's underscore run underscore pquery, which uses the pquery client, or it might be underscore pquery underscore run. I can't remember the exact order. So these scripts very quickly get you to set up a data directory somewhere in volatile storage, start the server, check if the client is up, and run the test case. So all of that happens within a few minutes, and you have a near one-to-one match of the original system on which it was produced, because this was produced by Reducer as it was reducing, and straight away saved the test case as well as whatever was necessary to run it to the file. And remember that in stage 8 of Reducer, it reduces the number of options as far as possible required for MySQL, and the underscore start script reflects that. So again, a very handy way of telling the developers exactly what is necessary for this issue to reproduce, which options are necessary. You might want to mention this separately in the bug report together with your short test case as well, but again, it's all there for the more savvy developer to go and debug. Okay, so after you've executed the particular test case, you can have a look into the error log file, which is stored there in the dev.hm epoch directory, and in there you will find whatever was necessary, whatever the bug SQL test case that you've executed has produced. Then there's also underscore GDB, which brings you directly to a GDB prompt in connection with this test case, and underscore parse underscore core, which basically as soon as you reproduce the issue, it will have a core file in the data directory of testcase epoch, and this creates the epoch underscore std and .gdb and underscore full.gdb files, which are just a standard and full GDB stack traces of all the threads. So very handy, you can run to this whole test case and have your full stack traces within a matter of minutes, and the developers can use this too, right? When they're testing, they want to jump into GDB, they want to get all the stacks, they might do a few iteration loops in their programming, and then all you have to do to get a completely fresh data directory is just run that init again, run the start again. You can kill off whatever is there in terms of MySQL D processes running in memory that are related to this test case, obviously, etc. So all of these scripts are there, they're produced by Reducer. You can jump ahead and go and have a look at a little bit more detail about these later on in this episode. It's probably about 70% down, 70 to 75% towards the end, and skip this part until you really need it. Okay, so let's get started. So if you haven't got Percona QA yet, go ahead and branch it from Launchpad. Of course, you want to install Bazaar first before you do that, and once you have that, it's already there on my machine, you can have a look at the file reproducing and simplification. So a high amount of issues, 85 to 95%, as I mentioned previously, reproduce very easily. So we run our pquery run, we run pquery prep reducer that reduces a bunch of reducer scripts. We clean our known issues that are there in the text string file in Percona QA, known underscore bugs.strings, and we run our result scripts, and then we just have to run our individual reducer. So very straightforward and easy. However, there's a bunch of issues that fail, and here is a list of all the things that you can try step by step to still reduce them, and let's start going through them and understand a little bit more what we can do. So we've looked into skip fee, the verify stage before, how we can turn that off, but you've seen there that you can turn for sporadic on. In other words, we can turn skip fee on, which will also turn on for sporadic, and this will make it faster and easier. So there's 10 threads, and you remember how you can set multi-threads to change that number. And you want to stop somewhere when you have 5 to 10 lines left and reduction doesn't seem to be progressing much anymore, and then you can add it manually further if needed, or if the issue proves non-sporadic, then you can of course turn for skip fee and for sporadic back to 0, and you can run it through Reducer again, and it will go to stage 2 and line by line reduce and then clean up the SQL. Okay, so the next item, it would be good if you understand this. So sometimes it's unable to reproduce an issue and you think, what's going on? And it's very hard to understand. And then you start looking into the SQL replay file, which is there in the subreducer or subreducer directory normally, like we've seen in the past, and you look at the MySQL client log and it says no connection, trying to reconnect, unknown MySQL server host, and some random string. So what has happened is somewhere in your SQL input file it had a / something, and this has pointed the MySQL client to another server. So what you want to take is this random string and search your SQL file for that random string, and it has pointed, probably using one of the / commands that are available in the MySQL client, at another server. And so you want to remark that line or just delete it or something like that, and then probably the replay will work just fine. So with pQuery, this doesn't really matter because it doesn't happen, because with pQuery the replay connects each time that that a particular line of SQL is executed. However, with the MySQL client, as soon as it tries and connects to another client, it will keep hammering the client with all these statements, but they're not going to get through to the server anymore because the client thinks that it had to connect to another server, right? So if you run into that one, it's relatively easy to fix by just looking for that random string and deleting that particular line. Hopefully it's not needed for the reproduction of that particular issue. Okay, the next item, so somewhat similar to this one, we want to check the client output log, and notice that the client could be either the MySQL client or pQuery for any other issues that we see which clearly indicate that something is going wrong. And so, you know, for instance, it might be running into another crash, right? MySQL server has gone away messages, and then when you check their error log, you find out that the server has been running into some other issue. And for instance, this can happen when the other issue is sporadic and maybe very low sporadic in a way that, you know, 8 out of 10 runs would reproduce this issue, but somehow you got through one of the two options in one of the runs and it ran into another crash. So this happens too. Okay, so if you have replay issues with CLR versus MTR versus pQuery, then you should note that MTR by default sets default storage engine MyISAM, and of course that can lead to very significant differences. So if you have a create table statement, create table t1 id int, and you don't specify the storage engine, then it will use the default storage engine. And so if you're replaying with MTR, then you know it might be creating tables by default as MyISAM. So just watch out for that particular thing. Okay, the other thing is when you're trying to reduce and you've set the text, you want to use the simplest version possible. So, you know, let's say for instance that this is the particular assertion message, then you want to just limit that. It's regex aware, so you can use regular expressions, but you want to just make it as simple as possible. For instance, there are certain items that don't parse correctly, like maybe exclamation mark or square bracket or something like that. You just want to make it as simple as possible. You don't have to go too crazy. Like for instance in this case, you might just go for scale any character precision, and that's just a regular expression for any character repeated any number of times precision. For this text to appear in the error log is highly unlikely unless it's this bug. But of course you could go scale any character equals any character precision and so on. You could make it more granular. To get a good ID, try a few times with text string. Have a look at known underscore bugs.strings, and you will see how text strings generate how text strings does it, and then you can make your own versions. Now, if you want to add something to the known bugs, then please use text string, the text string script, which will output a text string for a particular test case, already taking care of a lot of these oddities. If you go and have a look in the text string script, you can see here that it's already covering quite a few of these oddities for you, so that doesn't have to happen anymore. If you find any particular issues that text string isn't covering yet, I don't think there are many anymore, if any, but yeah, please verify that it's functioning correctly for us. Just make a small update if and where needed. Like I said, I think most issues have been covered quite well. You saw how many bugs we logged, so it's unlikely that there is going to be some sort of assertion message that has a special character in it that we haven't covered yet. So in terms of scanning bugs, you can scan the error log and search for the assertion message, or find the first few crashing frames as shown by GDB, or even the C++ filled demangled version of the error log as we've seen in other episodes. So the issue might already be logged, and if you find that it hasn't been logged, that it has been logged but that it hasn't been included in the known bug strings, please add it there. If there is no case, add it to the .no testcase file instead, please. Okay, and very similar to that first item there, maybe I should move this up. It's probably a good idea. Just move this up and put it directly here, so by the time you see this file it would have slightly changed. So when you set for skip v, it automatically enables that for sporadic, and it will skip the verify stage and immediately goes into multi-stage 1, and so you can let it sit away churning for a few hours to see if an issue reproduces, and it's great for highly sporadic issues where the verify stage might fail, or it might just go into using too many threads. Okay, and I've just moved that back here because the next point actually related to it. So if you if this wasn't successful, then of course you can increase multi-threads to 25 or even 40. You might just want to make sure that your server can carry it. And I just got a few more bits of information there as to what you want to do, what your server, ensuring there's enough space, because you know all of this is running on DevHSM, DMPFS, and so you want to make sure that there is enough space for all of these MySQLs and all of these threads to be running, etc. Okay, the next item. So this is something that at some point we saw quite a bit. So when you start with a long test case, it showed as, for example, non-sporadic, and it's gone down all the way to 500 lines, or maybe it showed as sporadic and it has gone to 500 lines. It doesn't matter, but at some point it stagnates, so it doesn't happen too much, but it has happened for a while there. Then just stop reducer, set for sporadic is 1, so in other words we're going to force the sporadic mode, and but then what you might see is that the issue no more reproduces, so that comes due to the low reproducibility. So when that happens, you take the original test case and you pipe it twice into a new file, maybe even 3 times in certain cases, and you just run that through that new test case through reducer using that for sporadic setting, and that's great if a issue reproduced originally well and then stop reproducing around 200 to 1000 lines. The next item. So this is something that has worked in practice. So you take the same method, but you do it from the outside where an issue did not reproduce. You take the file 2 or 3 times, so in this case I used 3 times, and you turn for skip vs on, and it will go and try and reduce it. So I'm not exactly 100% sure why it is so that when you have a particular statement 2 or 3 times in a row, an issue is easier to trigger. I assume that it's because the issue is sporadic to start with, but it is so lowly sporadic and so easy to reproduce that very often it just does reproduce, but in certain cases it doesn't. So having it 2 or 3 times in a row just makes it easier and more smooth for reproducer to reproduce it. So don't get the wrong impression, these are all last resorts. As we said at the top there, 85 to 95% of issues you don't have to go through any of this, and if you include for sporadic and for skip v, just setting those 2 to 1, we're already way beyond 95, maybe we're at 97 or 98% of reproducibility. So you can see in this case it was one particular issue that we had to do this, so it doesn't happen all that much. Okay, the next item. So this is basically what we've seen in one of the previous episodes, to use the timeout command in the mode equals 0 options that are available in Reducer, so we'll just skip that. This is also an interesting item, so if you have done a lot of pQuery runs, you could simply go ahead and at some point delete all the old reducer.sh files and just run a new pQuery prep reducer when you have done a bizarre pull on the MySQL QA tree and also on the ranch tree, because it's regularly updated, both the reducer as well as the QA script, and so something new might have been integrated. It's less now than it was originally, but in the early days we were making so many changes that this was a good method to apply. Okay, so if you've done a pQuery run, just flip the pQuery mod around. You might just want to try 0, which uses the MySQL CLI for replay instead of pQuery, and for some issues that could improve reproducibility again. Okay, so this is a slight combination. You could do grab the test case twice at some point during the simplification process. You could turn pQuery mod to 0 to use a CLI, etc. So you can combine all of these IDs together. Now, with using pQuery modus 1, you can change the pQuery binary, for instance from pQuery, which points to the Percona server client library included, pQuery compiled with the Percona client libraries, to pQuery MS or MD, which is MySQL Server and MariaDB. So using a different pQuery for replay sometimes triggers an issue that was hard to reproduce, maybe just tiny bit of difference in how the clients talk to the server. In some cases it must be quite a bit because the resulting binaries are very different in size. Yeah, so the idea is similar as setting pQuery mod equals 0. We're just using another binary for replay, right? Okay. Okay, so you could interleave your SQL file with select sleep 1 after every command. It will cause a slower replay. There's the command to do so, but you know, it might trigger a certain timeout. Okay, so common sense, if you get really stuck, analyze the stack traces and the core file. So it just goes on a little bit about, you know, how you could make your SQL more uniform, analyze every little issue. So, you know, this is for really hard to trigger issues, and you know, you can increase the number of threads. So by now, if you get to this stage, we're talking about very hard to reproduce issues, and this might be 1 in 100, if not 1 in 200 or so. Okay, so what you can do in this case is, the next suggestion is, you can take a partially simplified SQL test case and run it manually using, for instance, the source command from the MySQL command line interface against MySQL. And if it crashes and it's the same crash, you can again set pQuery mod equals 0, or you can replay the test case against another version. For instance, for us, we can replay it against upstream, and does it crash there too? You can change the version, you can point it to a different vendor and change the my base directory, etc., right? So, you know, that might increase in certain cases the reproducibility as well. Okay, so the next one is quite interesting. So review the code, and this is actually talking about the actual MySQL code where the bug happens, and add in SQL specifically related to the area. So we're talking a little bit about interleaving here. And so the case that I had there was, you had a debug assertion that was being hit, and the transaction here was the comment was here talking about a transaction and talking about, you know, the read isolation level, etc. So what I did is I add in a set of 20 different queries with set transaction isolation level, start transaction, commit, and auto commit on off, and so on. So I just grabbed those commands from main.sql and customized them a bit, and then I inserted them into the SQL file that was already, and I changed the replay file generated, so the run pquery, by removing the no shuffle option, increasing the threads to 150, and setting queries 1 million. And so then the issue replayed quite okay. So one thing that I haven't shown you yet is how Reducer creates these handy scripts. So when Reducer works, so it creates all of these scripts, and here I've been working with several reducers and several SQL files, so don't be confused by all of these scripts here, but let's just take one example here. So Reducer always creates these handy scripts, which are great for reproducing issues. They are nearly 100% match with our system. We upload them to a bug report. In fact, it generates all of these scripts, and then it makes a little tarball, and you can just upload the tarball and to the bug report, and it will have all of these handy scripts in it. So it will have a start script, a stop script, the SQL file, the run file, the parse core, MyBase, which is basically the pointer to the MySpace directory, the fresh re-init GDB connection straight into the core file and the client. So normally we could do something like start. Okay, and in this case I've previously deleted this file already, so it won't work here. But normally we go start, have a look if the client is up and running, then we could run, or in the case of pquery it would be pquery run, and when it's run and it's generated the core, we could go GDB, which would bring us into the GDB command line straight away connected to the right MySQL and the right core file. We could also go parse core, which would generate the two GDB text files, the standard and the full backtrace of all the threads, and we could reinitialize. Oh, actually, before you start, you want to init. Let me just try that. Maybe the files are there still. Just 1 second. Oh yes, my mistake. So first we go init, then we go start, and then we go client. Okay, great. So there's our client, and then we would execute some SQL. So let me just grab a simple crashing test case, and here you can see that it's lost connection to the server, and so if we go GDB, it will bring us to the right MySQL D. In this case it doesn't look like it might be the right one. It's looking for MySQL debug. Okay, slight little mix-up because of what I was testing here, but you can see how it would bring you into GDB. And then we have the parse core, which would generate the straight away the backtrace of all the threads, both full and standard. And so the only thing that we should normally change if we have uploaded this to a bug report is the base directory, and you could point it to source directory if you like, and you can change malloc if it's required, but normally you just change the MyBase directory. Then you can use the init script, then the start script, then the run script. It will execute this SQL. You can open with the client if you need to, and you can connect with GDB. So all of these scripts are generated by Reducer, and it just makes it really great, because it allows you to still, after the Reducer session, very easily upload this bug report to the bug, and at the same time have an almost 100% match with our system as soon as you set MyBase to the correct directory on your machine and execute these scripts. Okay, so coming back here, okay, so that makes a bit more sense now. So the SQL file is reduced by Reducer. So in this case, the issue had already reduced. There were a number of lines left. The issue wasn't super reproducible, so but by adding about 20 queries of these particular types of queries, because we knew from the source code that that was the particular issue, we made a highly qualitative bug, and in this case removing the no shuffle. And you will remember from the last episode how we were talking about the flag that swaps no shuffle versus shuffle. So in this case we removed no shuffle, which meant random replay, good number of queries, good number of threads, and sooner or later, you know, with a small original test case, 20 extra statements, that bug is going to be hit very easily. And that was the way that that particular bug report was logged. You don't really have to do this very often, but sometimes you might just want to jump one version back. So instead of using the add that you're working with, just jump back to one add, and even potentially the original test case again. So the randomness and simplification chunk deletion may take a very different route this time, and that works quite well. Okay, if all else fails, set modus 4 instead of modus 3, and it will look for any crash. Of course, you know, because it's randomly chunking, it might run into different crashes. So, you know, it's not really a very helpful suggestion. Okay, you can open the SQL file and execute the following in VI. And that will get rid of all the command lines. So that will only really help for command line replayed issues. So if you tried all of the above, for, you know, the reproducibility for all issues is near 100%, and you very often don't have to go to these extremes. Like when we're looking at these last items here, all of these are just for one or two cases that it happened, or maybe it was some ID that came up while we were working on an issue. So out of the few hundreds of bugs, there were maybe 2 or 3 or 4 special cases, and then we had a number of IDs that were added into here as we went along. But otherwise, most of the issues very straightforward. Just run it. Just run your reducer scripts. They'll reproduce just fine. For sporadic and for skip fee, okay, you could do that, and otherwise, maybe just having a good idea about some of these exceptions, like the storage engine and whatever, and maybe how you can do hangs, etc., will help you to nail down all the odd issues out there. Okay, great. Well, that was it for episode 10. I hope you have a great day. Hope to see you for episode 11. Bye.